Okay, now this is the final section of the Firenock Dealer and Enthusiast class. This is after everything said and done. After you learn the knacks, you learn the vanes, you learn the inserts. Now, how do you put it all together? You know how each capability of each other. Now we're talking about the individual step-by-step procedure to push them all together. Like anything else, when you get the shaft, you want to buy the most perfect shaft you can find, or you can afford. Like all shafts, there's a few characteristics everybody should understand. When you buy a shaft, there's two things. The first, spine number. What does that mean? The spine number is the number that the standard in the industry. That means when you hold an arrow at 27 inches apart and put a weight of 1.92 pounds, how much does it drop in the center? If you say 300, if the arrow say is a 350 spine, means that when you support it at 27 inch with a 1.92 pound, this arrow will drop 0.35 inch from the center. That number is also telling you what is the strength of this arrow. That means when the arrow was applied force to it, how much will it flex? That's what the spine number is. The next number you're going to learn is called strictness. Unfortunately, the strictness numbers is really over-exaggerated or overrated. Anybody want to guess what does 1,000 inch mean? 1,000 strictness. That means that when you support this arrow, if I can remember correctly, at 30 inch, this point, at this point, a laser beam come down in the middle. When you turn this arrow one full turn, if the laser beam do not exceed 1,000th of a variance, this is a 1,000 strictness arrow. What happened to the arrow? It's perfect here, perfect here, perfect here, and the arrow is actually S-shaped. This is still a 1,000 strictness arrow.
Yep.
So how good is that 1,000 strictness?
Amazing.
It's useless.
Yeah.
So that's the reason the only company I know that actually measure an arrow, the only way to measure arrow is have more than 3, most probably 7. With 1, 2, 3, 4, 5, 6, 7, and we make a full turn, all 7, say 1,000. This is not indeed 1,000 strictness. Otherwise, as I say, if what happened, the arrow is perfectly like this, like a dollar sign towards this straight line.
Yeah.
The machine for Gold Tip or Eastern or Victory or Carbon Express is still say 1,000 strictness.
Huh.
Now, the moment you cut something here, now you're holding this point and this point on a curved arrow. How strict can it be? So that's the reason when you first got an arrow, you really want to put on a spinner.
Yeah.
To at least get a rough idea how good it really spins. The next thing you do, Gold Tip Kim Gillingham said, if you got a 30-inch arrow, a 32-inch arrow, you only need 29 inch. The best to do is cut 1.5 on both ends, which is a very smart thing to do, unless you're shooting Victory shaft or the old Trophy Ridge shaft, because those are taper shaft. That means the moment you cut them, the insert won't fit, the nut won't fit, because they're tapered.
Yeah.
That's the reason we suggest people, in most cases, cut no less than 1 inch from the back and the rest from the front. That will give you a reasonably good shaft. The next thing you want to do after you cut the shaft out is to square it. This is critical. Use 150 degree sandpaper, square the shaft on both ends. After you finish that, you follow the insert process, whatever insert you use. You notice I still haven't talked about spining the arrow or indexing the arrow yet. You know why I didn't say that? Because at this moment, none of those mean anything. Give you an idea. If on a 32-inch shaft, if I spine this arrow at this moment, assuming the spine is indeed on this label, the moment I cut, say this is a 32-inch, I cut 4 inch in the front to make it 24 inch. Because the shaft is a spiral wrap in most carbon, the moment you cut any part of it away,
Spine's going to change.
your spine center index is going to move. The moment you put an insert on it, you also block a section of the carbon. The spike index is also going to move. And in most cases, it's better off to put a knock in it because you also block a section of the shaft. So my suggestion, if you want to do the ultimate and don't mind the work, instead you put insert in and you also put a knock in and then spine it. Now what does spining an arrow means? There's a lot of theory behind it. Some people say that you're looking for putting on a frequency meter and then using laser to find the oscillation, ideal oscillation cycle. But that is only from one end to the other end. And I have no arrow in this my life that was hold on one end and flex on the other end only. You always flex like this. So I don't believe in that theory. But some people think that is the best. Well, we can argue that in academic. But in most cases, from what I've learned by building 2,000 arrow bows so far, since every one of them fly reasonably well, I believe what I believe is indeed correct until somebody will prove me wrong. Then I will relearn. I believe that if you put on the maximum ability of this shaft after you build it, and you put a weight in the middle, and maintain that weight, and rotate the shaft until it finds its first and second natural bend. And whatever the first natural bend is the first bending direction of the shaft. The reason I want to go to this direction instead of using numbers, because on a normal when you spine an arrow, you're using a meter. The meter only tells you what is the lowest point and the second lowest point. It doesn't tell you the bending back strength and speed. It's like telling you a plastic spring and a steel spring of 5 pounds is identical. It's like telling you a steel coil and a bunch of rubber that you can push down 5 pounds to have the same bounce back ability. Answer to that is absolutely not.
No.
What you look at is the strength and the reaction of the shaft, the first reaction of the shaft. So maybe you have two numbers, one says 0.357, the other says 0.351. But the fact is that the 0.351 is faster when it bounces back, or more visual, or more definite. Which one do you think you should pick? The more definite one. And that's the reason I created the PAPS system, called the Arrow Preparation System. When you put the PAP system together, you can see that instantly at that very moment. Very easily, you want to put it as far out as possible. The moment you push this down, the arrow will snap to 1 and 2 positions. You want to find the one that is more obvious. Just in case for your reference, if you find the wrong one, you are not that off because they are always within 180 degrees or 170 or 160 degrees apart from each other. Just in case you pick the wrong one, you should be able to knock tune it and get it out of the way. So it's not that disastrous. But imagine this, if you are on a basic system of, now let's look at this diagram so I can show you how close we can get. This is an arrow. This is its oscillation plane. Just in case if you are off by here or off by here, and using this point, or this point, you are all within the knock-tune capability because you have one vein, second vein, and third vein. You are still within this plane. You can easily knock-tune it. But if you do not do the spining, and the oscillation cycle happen to be this, how do you knock-tune it out? You can knock-tune easily 15-degree variance.
Yep.
But you can't knock-tune 90 degree. Now that is reason it becomes so important. And with anybody like Walt White, Tim Gillingham, or Dan McCarthy, within 3 shots, he will knock tune this arrow perfectly if it is within reasonable spine.
So you want to find your high point of your spine before you fletch it.
Exactly. But at that moment, you'll refinish your knock, your inserts, and so
Yeah.
on. The only thing with the perfect method is that you indeed have to remove the knock to flush the arrow.
Yeah.
Because the arrow wing jig need the knock.
Yep.
But remember, both ends are perfectly squared.
Yes.
You did all those already. Now the only thing left is that after you transfer, you say, aha, this is indeed the high point.
Yep.
You laser marked it, transfer the arrow wing jig, that's your 0, and you fletch it.
Yep.
How good is the arrow going to be?
Perfect.
Don't you like that whole process?
Yeah.
Now look at the entire process from beginning to the end.
Mm-hmm.
What part's missing? None.
Good.
That's the reason this is, I believe, is the last step.
Yep.
The only other step that will make it better is putting a compound miter saw and miter this shaft at 45 degree here, and miter this shaft at 45 degree there, so the insert will cap in the first time perfect. That's what I'm gonna do next year. But I don't think we need it that soon.
No.
This is good enough for any size that's under 204. Anything beyond that is size that is over 245, or the S size.
Yeah.
Now if you look at the PAP system, this is what the PAP system is with the vibrational module on top.
Yep.
The whole idea is that, see the final version, we have 0 right here and both sides.
Yeah.
And then you have another tape on the back with 0 to 36.
Yep.
So you just put the shaft there, say 38. You instantly know that you are putting 19 on each side. What? Is 19? No, 38.
19, right?
Yeah, no, this is a 28. You put 14 on each side. So you're able to use the 14 on this side and 14 on that side.
Huh.
So this whole system is trying to get you to what you want to do a lot faster.
Yeah.
The traditional way of spining arrow is that you find a dozen arrow, you plug both things with a perfect ear plug, and flow it in a bathtub and see which way it rolls.
I didn't know that.
That doesn't work on carbon. Do you know why? The carbon is not a homogeneous material. Aluminium is a solid piece of material. They are all identical material. What's in carbon? Resin and carbon fiber.
So it absorbs the water.
Mm.
No?
Just because it's heavier do not mean it's weaker or stronger. Because the perfect match of carbon and resin is indeed the strongest, do not mean that the weakest side is the lightest or the heaviest. It don't mean nothing. So the whole floating method has 0 value on carbon. Because the weight and strength are no longer in ratio. Just because it's heavier do not mean it's strongest or the lightest or anything. It's all a crapshoot. So this method becomes the only method that's viable. And if you take a closer look at this, see this bearing?
Yep.
It is actually a custom built bearing. See this part, there's no hole here.
Yeah.
And that's a perfect crown.
Yeah.
What does that mean? At this moment, how many contact points is on this shaft?
2.
6. 2 each.
Oh,
1, 2,
yep, 2
3, 4,
each.
5, 6. If this is a flat bearing, how many contact points would they have?
A lot.
Not just a lot, we have 8.
Yeah.
Because this point, when you push down, the 2 edges of the bearing is touching it.
Yeah.
Now you just added a third. And you're also pushing pressure on the bearing towards one side. This is no longer on a tangent. This is a crown, see that?
Mm-hmm.
So the bearing is riding on this edge. The moment you got a square bearing, you'll be riding on the square edge.
Yep.
It's pinching the shaft now. And not to mention, see with the vibrational module, it's sending all frequency down into shaft. And what happens when you get frequency? The shaft and bearing is doing this. What happened to the friction? Have no contact area. Friction go down. That's the reason you feel it so much easier. And that, my friend, just concluded the entire aero building section. Now just before I finish, any part you want me to revise?
No, that's made it a lot more clear. A lot more.
Now, I didn't want to go to aero rest or the rest of them, because those are not aero building process.
Yep.
And I would prefer you revise it on your own.
Yeah.
And I will hold different classes for different sections.
Okay.
But for the entire aero building process, from beginning to end.
Alright.
Now, if you go home and you read this manual,
Yeah.
I know the first section you may not be thrilled because it's technically on all the technicality of the aero,
Yep.
of the finite. But the moment you understand it, you're able to explain to your customer much better.
Yeah.
Because they don't know what it is. They don't even know this is actually a microprocessor, single processes, and so on, and how the light actually worked.
Huh.
But the moment you understand it, based on your customer base, they will have no choice but to buy this.
Exactly.
And of course the jig.
Yeah.
I mean the laser system and so on. It has made your life so much easier. And the moment you understand how the chucks interact, why the water level is part of the deal, and why on some customer, they're very traditional, they insist on feather and nothing else. Feather it is. Make sure you put right hand feather. You know they're going to turn maybe 2 turns in the first 20 yards.
Mm-hmm.
It's their choice. It's their passion. I will not go anything against what they said. And those are the broadhead that you can use on AeroVing 2 and AeroVing 3.
Huh.
I published everything. And of course, this is a step-by-step procedure, how the functionality and how the glue works, and the specification of all the inserts,
Yep.
the bushings, the aero insert A, the target, and the entire history, how I built and the why I built aeroboats. You may not learn it now. Trust me, within 2 years, if you don't have one that do this, I will be surprised. And if you want anything with the ultra high-tech stuff, they are on here.
Okay.
So I think that pretty much concluded your entire training.
Yep.
The only thing I need from you is that I need your address, phone number, and so on, so I can send you your finished certificate so you can hang on your wall.
Alright. Can you show me the proper way to fletch an airway too?
Sure.
So
That I
that's
can do.
probably gonna be one of the first things I start doing is fletching.
Good. I can definitely do that. See, this is the base. After you have that arrow, you mark the index, okay?
Yep.
After the index is done, see that right here?
Yep.
There's all this index. Rod only want to do 3 fletch.
Yeah.
So y'all may not have all this index on it.
Okay.
The reason I have all this index on it because what happens when you want to fletch something that's a little bit more challenging, like the PSE Type 15. We're fletching like this,
Why would you want to do that?
because that's how the bow shoots.
Oh.
The scope is on top,
Yeah.
the rail is underneath it. That's the only way the vanes will work.
Oh.
How do you fletch them?
Right there.
Right. What you do, just for the record, since everybody's still recording, right? What you do is that first you spine this arrow. You find the index, and you put the index on 120 degree. Then you put this in. Then you roll it back to 0. You fletch the first one. 60, second one. Then 180, 240 will give you this. Index and perfection. Or if you want to do 3 fletch, put it back to 0, put the arrow in. See this line right here?
Yep.
This is the most critical thing of the AeroVing jig that no jig ever on this planet have.
Okay.
This is design patent. Nobody can put this line here. Guess why? Because when you do this, what do you just got?
A perfect.
A reference point. Of course, you can use a laser system to find it, or you can actually look down the shaft.
Jeez.
If you can find this perfect 0, what does that mean? If we know our index is plus and minus 1/72 of a degree, and I rotate it 120 degree, guess what that is? That's perfect 120. Now you know how you can refletch.
Yep.
When you off one vane, how many veins do you take away? You put back 1. Now when you down, I'm in the process of putting arrow vein. Now you notice that in the menu on page 8, this is the most important thing. Step-by-step arrow fletching procedures.
Okay.
Those are on the top part is the equipment list.
Yeah.
In your arrow vein, your new shaft, your precision index vein jig like this one. This is the part that most people skipped. You need 2 bottles of acetone.
Yep.
You know why 2 bottles, not just one?
Why?
Because cross-contamination. When you stick your arrow shaft into the acetone to clean it,
Yeah.
what are you doing? You're putting dirt into the acetone.
Removing the.
You're removing all the residue, dirt, whatever on the acetone. You take it out, you wipe the shaft clean. The shaft now theoretically is clean, but the acetone cannot be trusted because you have all the dirt from the shaft.
From previous arrows and.
Right. Now you need a big bottle, that's to clean the shaft. You also need a small bottle, see that? 2 bottles.
Yep.
The second bottle, guess what that's for? That's for gluing. You clean the shaft already, right?
Yep.
Then you open the clamp. Based on indexing, using this index,
Yeah.
you put your vein exactly in the right spot. Usually I will put it on the end if you are doing regular bow.
Yeah.
The beauty of the arrow vein is that the further you put it, the more better it shoots, except one condition. When some people pull back their bow, they don't like the vein touch their face. So you have forced them as far, as close to the back. Because this is a wing system.
Yeah.
Remember every single airplane, how does the tail rudder goes? Beyond the airplane itself.
Yep.
We can't do that on arrow. So we put it as far back as possible for stabilization. So you want to put it as far possible as you can imagine or tolerate. For this is the best position we can find. This is what you do. You now use a Q-tip, a clean Q-tip, dip into the second bottle of acetone, that's for gluing. You swipe from top to bottom, clean once. At the moment the liquid is there, you instantly dry with the other end. What did you just do?
Clean the vein.
Not just clean the vein. Let me show you this. This is what mechanically have happened. This is the vein surface.
Yep.
This is all veins in the market have released material. Another one, the oil compound in the vein. Where is the oil? It is not on the surface.
No.
It is embedded. In the vein. The moment you put acetone, guess what happened?
Releases it.
It releases everything off. Now the acetone come by and grab hold of all this. The moment you swipe the acetone on the second part, guess what happened? All these oil molecules above and on the edge or below the surface is removed. Guess what's left? Empty void.
For the glue.
Now you put AgO 600, which is a smaller molecule significantly, because solid acrylic is a very simple molecule compared to a long molecule of oil. It's flow right into it. What do you just got? Roots.
Yep.
And then you push this together. Right and down. Now you know why I know that the moment you put the glue on it and push it right there, that vein is going to hold 680 pounds in 9 seconds. And 12 seconds you're ready to shoot.
Mm-hmm.
If that's not strong enough and fast enough, I don't know what is. And that's how you fletch the arrow vein. Now when you do it, this is a procedure, now watch it carefully because it's important. You want to put your vein right here, see it touching the end?
Yeah.
And then you let the vein drop down by itself. See the magnet, we actually hold it and pull. See that? You actually pull your hand down. The more you go down, you put your hand right here and hold it for 5 seconds. And you release. And wait for 9 seconds. What you do is that you click on this clamp, you press down. When you press down, what happened? Remember, you got an air channel on the vein. You said it?
Yep.
It's really air channel. The moment you rotate, you pull, you have perfect vein. That's the procedure.
Yep.
Now, this whole procedure is on video on my website.
Okay.
So you should go and watch it one more time.
Yeah.
Now, before you proceed, I know it's a lot of homework.
Yeah.
But if you really want to watch my stuff, read the manual once.
Yeah.
It's a lot of work, but trust me,
It's worth it.
you only have to read it once. And if you need more, you can review it.
Okay.
Is that what you need?
Yeah, that cleared a lot up, cause.
Now, another thing is because rod stuff is pretty simple.
Yeah.
He's a single size, you don't have to use this system. See this system right here? After I balance this is straight, right?
Yep.
If this is an adjustable hook, you see this adjustable hook right
Yeah.
here? How do you guarantee this shaft is in this level? You couldn't.
Mm-mm. Huh.
Now you can.
But his isn't like that.
Because he already got a red hook, which is a fixed size,
So it's never not gonna be level.
he already predetermined.
Yep.
But when you want to do adjustable, everything had to
Yeah.
be checked. Now you know why there's a level here, and there's a level here.
Okay.
When you have variation, you always read reference.
Yep.
That's the reason they are there. And for the customer who insists to shoot, whatever reason, to shoot helical, or the customer is shooting super low speed, like 240 feet per second with Aerovane 2, that's not enough lift. What do you do? When an airplane is landing, what do? You increase the down flag, which means the angle of attack is released. See this piece right here?
Yep.
You now actually increase the angle of this. The vane now is this.
Yeah.
The angle of attack is like landing. So now that's the reason we're able to use Aerovane 2 even on bow as low as 160 degree. By increasing the down flag. When you do that, you put your thumb right here. Let me lock this thing solid first. You put your thumb here and then you put the vane down. So in other words, your vane is now offset. So just in case you got girlfriend or some kid's daughter or son that cannot shoot high speed bow and they want you to flush, you know the Aerovane 2 won't work on the straight because they're shooting under 250.
Yep.
You have to increase the angle of the attack. That's the reason the laser marking here on the hook. This is 0 degree. That's half a degree. That's 1 degree, 1.5 degree. Half a degree will go to all the way down to 220, just like the numbers here.
Yeah.
You can see right here, you already tell you what angles you need, and so on.
Alright.
So read those. They will tell you how far you can go based on what you need. As a matter of fact, I think I also have it revised again in here too. See that? That will give you that angle.
Yeah.
Have you ever adjusted the magnet now? The magnet is not touched. Which means that your reference is always perfect.
Yep.
So after you finish that job, you can do back your original job. What I recommend is that if you do multiple arrow sizes, the best thing you can do is buy multiple jigs. Each set of jig for each sizes. Otherwise you'll be changing back and forward, which is not a fun thing to do.
Yeah, like Steve has.
Now you know why you do that, because the person says, change it. No, they are not perfect. Now you know why Rod likes Steve's stuff.
Yeah.
Because his stuff is close to perfect as possible.
Yep.
Alright, that really do conclude the entire session.